All right, good morning, chemistry people. Today's topic is the second part of our molar chemistry YouTube videos. Yesterday, in part one, we looked at converting particles into moles. And we said moles was important because in a balanced chemical equation, the coefficients, the big numbers that we use to balance the equation, we said those actually represented moles or amounts of each substance, right? The word mole basically means amount, and that amount is 602 hexillion, or 6.02 times 10 to the 23. So today what we're going to do is we're going to find out how to convert the number of moles of a substance. So if we know how many moles of oxygen or aluminum chloride or sugar or whatever it happens to be that we have, we're going to be able to figure out how it converts into mass. Now, why is that important? Why do we want to convert moles into mass? Well, in the real world, if I need a substance for a lab and we're out of it at the school, I'd get on the phone and I'd call one of the scientific supply companies and say, hey, we need some of this, right? If I go to them and, I'm doing my chemistry, I need 25 moles of sodium chloride for this reaction. I can't go on the phone and call them and say, hey, can you send over 25 moles? The people on the other end of the line are just taking orders. They may have no chemistry background whatsoever, right? And products are shipped and sold based on mass. If you go to the grocery store, all your powdered items for sure, and a lot of the other items are sold based on mass. And even your vegetables and your fruit, when you buy those, the greater the mass of apples you buy, the more you pay. So the world kind of works on mass, right? Chemistry works in moles. So to make it applicable to real items in everyday life, we need to be able to convert moles into mass. Plus, all of our scales in the lab, they work on mass. I can't put something on a scale and it tell me how many moles it is. I have to be able to turn that mass into moles. And we'll explain why I can't just pop something on the scale and be able to say, oh, that's 7.2 moles. We'll explain why in just a moment that happened, why we can't do that. All right, so let's get into our talk. See what I did there? Massive moles, right? The massive, okay, anyway, moving on. Terrible, terrible. All right, so in order to convert from moles to mass, right? I want to be able to turn that into that. Or if I have a certain mass or something, I want to be able to do this. So very similar to yesterday, there has to be a conversion factor. Now, if you remember yesterday, we had particles, I'll put it down here off to the side, and moles. All right, we had this loop yesterday, and we were able to go back and forth between them. And the conversion factor for in here was 6.02 times 10 to the 23rd particles per mole. So I had to go from the number of particles, usually atoms or molecules in chemistry, to the number of moles. I had to know that there are 602 hexillion, or 6.02 times 10 to the 23 particles per mole. Make that a little more L looking. So that's what I had to know. And one way I divided it, I believe up here we divided, down here we multiplied by this conversion factor. Well, the conversion factor for this loop that we're going to discuss today is something called the molar mass. The molar mass is basically the mass, so the number of grams, because we use grams to indicate mass. It's the number of grams per 1 mole of the substance. So I have a mole of oxygen gas. It has a certain mass. That's the molar mass. If I have 1 mole of aluminum chloride and take the mass of that, that's the molar mass, because it's 1 mole. So the molar mass is basically the mass of 1 mole of any substance. Now, the other loop, it was the same number every time. It was always 6.02 times 10 to the 23 particles per mole that we had in here. There is no steadfast fixed value for this. And I'll explain why. Let's say, for instance, we had carbon. I'll use the two elements that we discussed yesterday. Carbon's mass on the periodic table is 12.01. And we said yesterday in our mole lecture, the cool thing about a mole is if I have 1 mole or 602 hexillion carbon atoms, it will weigh 12.01 grams on a scale. So 1 mole of that will equal 12.01 grams on a scale. So the molar mass of carbon is 12.01 grams per mole. So if I was dealing with carbon alone, 12.01 would be the number I would use here. But then we looked at sulfur. And sulfur, if you remember, was 32.07. And we said that means 1 mole of sulfur, if we put that on a scale, it would weigh 32.07 grams. And then we talked about, well, carbon has less protons and less neutrons and electrons than sulfur. Sulfur is a bigger atom. So of course, if it's got more parts, and those parts make up the mass, it has a bigger mass. Carbon, having less parts, less subatomic particles, protons, neutrons, electrons, it has a lower mass. So if I'm talking about sulfur atoms, and I have so many moles of sulfur, and I want to know what the mass of that is, the number changes. For here, the molar mass for sulfur is 32.07. The molar mass for carbon is 12.01. And even for water, we can do it with molecules. Yesterday we worked out water, and we said water was 1.01 plus 1.01, so 1 hydrogen, a second hydrogen, and 16 for the oxygen. These are the values on the periodic table. And we said 1 mole of H2O would equal 18.02 grams. So if I took 602 hexillion molecules of water and put them on a scale, it would read out 18.02 grams. So if I was dealing with water, it had a certain number of moles of water, and I wanted to find, well, what would the mass of that water be? Or if I had a certain mass of water and wanted to know how many moles are in there, the number I would use for my molar mass is 18.02. Yet for carbon, it's 12.01, and for sulfur, it's 32.07. So there's no fixed number that goes in here, because the number of protons and neutrons that make up these different substances, whether it be an element or a compound, they vary. So we have to always calculate the molar mass, this value, before we do any work. I cannot convert moles into mass or go back from mass into moles without finding this first. If it's given in the question, great. If it's not, there's an easy way to figure it out. And we just kind of did it right here. All right? So the molar mass is the mass of 602 hexillion, or 6.02 times 10 to the 23 particles, atoms or molecules, of that substance. All right? So of course, if it's the molar mass, it's the mass, grams, per 1 mole. Now, how do we figure this out? All right, how do we get that molar mass? So what we do is we simply use the values on the periodic table. So here's our periodic table, and like I said, carbon was 12.01, here's sulfur, it was 32.07. Water, I took 1.01 and another 1.01 and added it to 16. So I'm using these same masses from the periodic table to find my molar mass to do this calculation. All right, so for example, the example I have here is C2H6, right? Ethane, a very simple hydrocarbon. And what I did is I wanted to find the molar mass of it, so I took carbon, which was 12.01, and because the formula has 2, I doubled it. And I added that to the 6 hydrogens. 6 times 1.01 on the periodic table. Each hydrogen is 1.01. So I add those numbers together, and I get 30.08 grams per mole. The molar mass is always in grams per mole. So basically that's what I'm doing. I'm looking at the formula, and again, names and formulas are going to be huge, and I'm looking at the components of that formula, the different atoms and the number of each different type of atom, and I'm adding that all together. When I add it all together for that formula, that's what this value will be. All right? So we can use that number like the conversion factor from before. So we look here, here's our number of moles just like here, here's the mass just like here. All right, and we know that mass is in grams, and moles, well, it's in moles. And so to convert it back and forth, if we want to go from moles to mass, we simply divide by the molar mass value. And if we have a mass of something and we want to convert it into moles, sorry, I did that backwards. That doesn't make sense. This is multiply. This one down here is divide. Don't worry, I've got it right now, finally. We'll do some questions in just a second using this. All right, we'll do a few examples. So to go from moles to mass, I multiply by the molar mass, right? So let's say carbon is, we know that carbon is 12.01 on the periodic table. So that means its molar mass is 12.01 grams per mole. So if I had 3 moles of carbon, I would multiply by that because each mole is 12.01 and I have 3 moles, it would be multiply. And if I had a mass, let's say I had 24 grams of carbon and each one is 12 roughly, I would divide that 24 by the 12 and know that I have almost 2 moles, basically. All right? Kind of like our eggs, our individual eggs and our dozens that we talked about. All right, so let's move this just for now and do a couple of problems that deal with this right here, okay? So I'm going to take this, I'm going to move it down here, very, very small. Moles, mass is in grams. We'll go this way and this way, and then we'll have the conversion factor this way. Grams per mole, that's the molar mass. And we know this way is multiply, this way, I'll put it inside so you can see it, is divide. All right, so I just rewrote that down in the corner here because we'll use it for our problems here. So our first problem, sample problem number 1. What is the mass of 3.75 moles of, we'll say, silicon dichloride? I'm just making this problem up and we'll solve it together. All right? So what is a mass of 3.75 moles of silicon dichloride? So I will do the answer in blue so it kind of stands apart from the question. The very first thing we need this. I need a formula, all right? Because I know that formula helps me with the molar mass, the grams per mole. I'm given moles, so I'm starting here. I have to turn it into here. So I'm going to multiply by the molar mass. Where do I get the molar mass? Well, the formula helps me determine that. So I need silicon dichloride, which is SiCl2. Again, names and formulas is huge. If you fumble on this step, it alters this and alters the whole question. All right? So off to the side somewhere, I'm going to add this up. I'm going to figure out that molar mass. So silicon, I have 1 of those. All right? So what I do is I grab my periodic table. And I look, silicon is right here. It's 28 0.09. Then I have 2 chlorines, so 2 Cls. So that means 2 times 35, 45. Chlorines right here, 35, 45. I have 2 of them, and I'm going to add those. All right, so I'm taking my 35, 45. I double that, and then I add the 28.09 of the silicon. So when I add up those atoms there, I end up with 98.99. So this is the molar mass. All right? I need the molar mass before I can do any of these calculations. So now I've got that. That is my grams per mole. Now, when I'm doing the question, right? When I'm doing the question, I always start with what I'm given. All right? So 3.75 moles. And I'm going to multiply. 1 mole is 98.99. 2 moles would be twice that amount. 3 moles would be 3 times that amount. 10 moles would be 10 times this, because this is the mass of 1 mole. So I'm multiplying here, times 98.99 grams per mole. When I multiply, moles on top and moles on bottom cancel, and the only unit I have left is grams. Grams will go right there. The moles are gone. They reduce to 1. And then I put that in my calculator. 3.75 times 98.99 equals 371.21. 371.21. So 3.75 moles, if I put that on a scale, that amount, the scale should read 371.21 grams. Does this make sense? We talked yesterday about the Trailer Park Boys and Ricky. Ricky on the Trailer Park Boys, not the smartest guy. Julie and Bubbles quite often have to go put their hand on his shoulder and say, Ricky, think. So let's think about this. 1 mole, when we calculated the molar mass, 1 mole, grams per 1 mole, was just short of 100. So 3.75 moles is just short of 375. That answer makes sense, right? So it makes sense in my head. So that's something to do when you're finished these. Think, or even before, think, what roughly should I be? As soon as I get this and I realize, okay, I've got 3, almost 4, moles. Each mole is almost 100. My answer should be 300 and something, close to 400. 300 and something, close to 400. So my answer makes sense. All right. So that's the first example. Pause the video, get this down if you need to right now. I'm going to erase it and we'll do another one together. Example 2. We just went moles to mass. Let's go backwards. So, our next question, how many moles of water are there in a 200-gram bottle? So what I'm going to do is I'll do my answer in a different color. We'll do it in red here. So, water is key. I've got 200 grams of water. Water, I know, is H2O. Before I can do the question, right, it looks like we're starting with grams. So I'm starting with grams right here, and I've got to turn it into moles right here, right? So I've got to go this way, from here to here. To do that, I need the molar mass, and for the molar mass, I need the formula. Well, water's a nice and easy one. So I know that I have two H's, which means I have 2 times 1.01 plus an oxygen, which I know is 16. And again, the 1.01 and the 16 are coming right off of my periodic table. So this is 2.02, and I multiply that, I add that to that, and we've worked out water before. So water is 18.02 grams per mole. All right, now I can use this information along with this. Always start with what I'm given. I don't start with that, I start with this. So I have 200 grams. And now what I'm going to do is, I have mass. To turn it into moles, I divide. Now let's say I didn't even know what to do. I'm kind of panicking. Maybe I'm doing a quiz or a test and I'm like, oh man, I know it's divide, I know it's multiply, I'm not sure. I know it's got to be divide or multiply. I'm not really quite sure. Here's a simple thing to do. Think about what you have to get. How many moles of water? So I know I'm trying to find moles. And now when I look at this, I have to think, okay, I've got grams here and I've got moles. To finish with moles, I need to cancel out these grams. So if at first I went multiply, now we know this is the wrong way because I'm given grams and I'm going to moles. We know the answer is divide, it's right down here. But let's say I panic about multiply. Think about this, grams times grams. That's not canceling it, that would be grams squared. The same way if we had like a number 7 times 7, well that's 7 squared. It doesn't get rid of the 7, actually it makes it bigger. So it can't be multiply, right? Grams times grams would square it. Grams squared seems weird. So I know that can't be it. It's got to be divide. Perhaps I just remembered it from here. Or I think about grams divided by grams. When grams divided by grams, and they're both on top, they cancel, they reduce to 1. And all I'm left with is moles. All right? Just something to think about. So 200 divided by 18.02 equals, and I get 11.1 moles. So I can actually move this a little bit closer. 11.1 moles. All right? Does that make sense? Well, let's see. I've got 200 grams of something, and each mole we'll say is about 20. 200 grams divided by roughly 20 gives me roughly 10, or 11 in this case. So that answer does make sense. All right, easy enough. We'll do another couple of examples, and then we'll get in for the big finish. Pause that video if you need to write that down or make sense of it. That's the beauty of YouTube. You can always pause my video, shut me up for a while, and work on the question. We'll do a third question here. All right. How many grams would, let's make up a number, 2.35 moles of, what are we going to do? Something nice and easy. We'll go with calcium chloride. All right, so how many grams would 2.35 moles of calcium chloride weigh? So if I put 2.35 moles of calcium chloride on a scale, what would that reading be in grams? So I'm looking for this. I've got this, and I've got that. So there's my key information. All right. So first thing I'm going to do, this is CaCl2. I need that formula. That formula helps me with this, the molar mass. So calcium, 40.08, and I have 2 chlorine, which means I have 2 times 35.45. And I go to my trusty calculator. Here's my calculator today. Purchased from Dollarama, one of the best stores on earth. And to do that, I simply take 40.08 and I add it to the two chlorines. 110.98 grams per mole. All right. So this is my molar mass. 1 mole of calcium chloride is this. It's 110.98. I've got 2.35 moles. So I already can kind of figure this out. If 1 mole is 110, 2 moles is going to be 110 plus another 110, so 220, and a little bit more for the 0.35. So my answer should be a little bit more than 220. Just thinking ahead, right? Doing our think, Ricky, think thing. So let's do our answer in blue here. Always start with what's given you in the problem. That's this value right here. So 2.35 moles. And to go from moles to grams, let's say I'm stuck again. Oh God, I can't remember. I know I've got to put this in there. And I know I'm looking for grams. So I want to keep this. I want to get rid of the 2 moles. Well, 1 mole is on top, 1 is on bottom. Top and bottoms cancel when I multiply. So if I forgot this, if I didn't have that, I could still figure it out with a little bit of common sense. So 2.35 times 110.98 on the trusty Calculator Matic 3000 from Dollarama. And that answer is 260.8. So, like we said, we knew it was going to be a little bit more than 220, 260, and that makes sense. All right. So, I'll do one last example. Pause the video if you needed to get that down. I already started erasing it, but you can go back a couple seconds if you need to. We'll do one more going from grams into moles. All right. So this is example number 4, and this time we'll use, you know, good old Jimmy. So Jimmy has, let's say, 3.78 grams, so only a small amount of sodium fluoride on a scale. What mass does the scale read? So again, if I have a highlighter, if I'm underlining things, this is important. That's what I'm starting with. I know that's my substance, and I'm looking for mass. So I'm looking for these things. So I'm looking for grams. I have sodium fluoride. Sodium fluoride, I'll find that out off to the side here. So NaF is sodium fluoride. This is a 1, that's a 1. That's a good formula. So to find the molar mass for that, I'm going to take an Na, and sodium is 2299. Again, this value is right off of the periodic table. If I bring that up, sodium right here, 2299, fluorine is 19. I've got one of each. I know that's going to end in that. So 99, 2 9 is 11, carry the 1, 41.99. Sorry, Calculator Matic 3000, didn't need you there. So there's my molar mass. 1 mole of sodium fluoride has a molar mass of just short of 42 grams. All right, I'm going to start with what they gave me. They gave me this. That's my first value. All right, and I'm at grams. I'm going to divide to get to moles. So divide by the molar mass. And even before I start this, 1 mole is basically 42 grams. I don't even have 4. So I'm going to have way less than 1 mole. My answer should be 0 point something. If I multiply this, I'm going to have 120 something. But my answer should be less than 1. 1 mole is 42 grams. I have less than 4 grams, so I should have less than 1 mole. So that's the difference between, that's huge if I divide or multiply there. I got to get that right. So 3.78 times 41.99 equals, I just multiplied that. I'm not supposed to do that. 3.78 divided by 41.99 equals. And my answer is 0.09 grams divided by grams. There's no grams. And I have my moles. There's my answer. All right. Easy enough. One last thing. Pause that video at that point. All right, I'm going to bring this back down really quickly, throw this in here. The big picture, this is pretty important. So, you can take pride in this. So now we know how to go from particles to moles and vice versa. We learned that yesterday, particles to moles. And today we can go from moles to mass. So now, because they both have moles in them, I can do this. Technically, I could go from particles all the way over to mass, but it would be a two-step thing. I can't do it in one thing. So it would look like this. If I join these two things from yesterday, it would look like that. So it would, let's take a look at it. I'm going to move this because I'm basically done now. And it would look like this. I'll erase this. I'm going to draw this nice and big. Now, on the back of your periodic table, you should draw this. If you have space on the back of your periodic table, draw this. You're allowed to have this on the back of your periodic table. So, number of particles we can change that into moles and back, right? And our conversion factor here is 6.02 times 10 to the 23 particles per mole. And we know that this way was divide, this way was multiply. If I connect the new work to this, we started at moles and we can go to mass, which is grams. And we know we can go back this way. To do that, I need the molar mass. This loop always uses this same number, the 602 hexillion. This loop, like we said, it varies. It depends on the substance because each substance is made of different atoms with different weights. No fixed number here. You got to use the formula. And we said this way was divide and this way is multiply. So technically, I could give you a problem now where I could say, hey, here's the mass of something. How many particles would that be? And so what you would do, so I'm giving you mass, and I want to know, well, how many particles is that? Right, the mass would be in grams. So what you would have to do is take those grams, turn it into moles, and then do this calculation and turn that into the particles, the atoms or molecules, right? I could also do this now. We could start at the other end. And I could say, hey, you have X number of particles. What would the mass of that be in grams? Well, you'd start with your particles. So I have X number of atoms or molecules. You would use Avogadro's number and turn that into moles. And then you would use the molar mass of, well, whatever the substance was. You'd calculate that, add up the pieces, and you'd get mass, right, which would be in grams. I'll do a short video after this one showing you how to do a few of these. All right? Anyway, hope everything was crystal clear. If you have any questions, comments, or concerns, please leave them in the comment section below this video or reach out to me through Edsby. Hope everything was crystal clear. Talk to you later. Bye-bye.